Hello Year 11, let's go through our mini test. The first question is about ionic salts, so we need to make sure we're thinking about precipitates, solubility and which things are soluble. We've got words to help us answer this first question in boxes, so let's make sure we read them. Lead iodide can be prepared by mixing potassium iodide solution and lead nitrate something. Well, it's got to be solution. Lead iodide forms a solid something. It's not going to form a solid metal because lead iodide is a salt, not a metal. We know the question is about salts, it told us at the start. So it's going to be a solid precipitate, that's the only other thing that can be a solid there. Please excuse my handwriting. To separate the solid lead iodide, the mixture is something. Not gas, definitely. It's going to be filtered or dried. Well, we've got to filter it first. So, filtered, it's going to go here. To obtain a pure sample of solid lead iodide, the solid is washed and then dried. Most people managed to get those last two marks. It was the solution and precipitate marks that people struggled on. Then we're given an equation, and whenever you're given an equation and asked to describe what you see, you should look at the products. If we look at the reactants, we've got zinc carbonate and hydrochloric acid. That's a solid and a solution, and we're making a gas and a solution. So what we're going to see, first and foremost, we're going to see the solid dissolving, and we're going to see a gas forming. And when we see a gas forming, we see bubbles, fizzing. Okay, let's look at the next page. Okay, so this is a 6-mark question, and it's actually not that tricky, but a lot of people missed out a lot of marks here. We're given 2 solid sodium salts, which are unlabelled. One is a chloride, one is a carbonate. How can we carry out a flame test to show that they're both sodium salts and describe another test to identify one of the salts completely? So we've got to describe 2 tests here. Firstly, the flame test. And what we're doing here, just going into our revision, we're thinking, right, how do you carry out a flame test? You're going to put the sample on a wire. Clean wire, a clean wire that we've cleaned in hydrochloric acid. I'm going to put it in a blue flame. And with any test, the most important thing is saying what we'd see if it was positive. So, see an orange flame. Okay, next test is a test to identify one of the salts completely. When it says that, what it means is to identify the cation. So we've got 2 options here. We can either look at the chloride or the carbonate. Carbonate, we'd add HCl, hydrochloric acid, and we'd see bubbling, which turns lime water milky. Chloride, we go silver nitrate and nitric acid, and we'd expect a white precipitate if it's a chloride. Brilliant. To get those 6 marks, you really just had to break down the question. It was asking you for 2 tests to completely identify the compound. And for any ionic salt, you need 2 tests. Okay. Water is often used as a solvent. The diagram shows the electrons in a water molecule. Only the outer electrons are on the oxygen. What type of bonding is present? Well, covalent. Should know that straight away because we are sharing our electrons. We've got a shared pair. Dot from the oxygen, cross from the hydrogen. How does this bond form? Both atoms share one electron to form a shared pair. So we're saying that each atom is giving one electron into the sharing pair relationship. Okay, water boils at 100 degrees, copper boils at 2600. Why has water got a low boiling point? Big key word here is intermolecular forces. That's the forces between the molecules, and for water they're very weak. So water has weak, we don't even need to say intermolecular forces if that's hard to remember, we can just write forces between molecules. Whereas copper is a metal, so it has lots of strong bonds. So a high melting point, a high boiling point. Again, please excuse the handwriting, just listen to what I'm saying. That gets us our 2 marks. It's about mixtures. First question, what term is used to describe two liquids that do not mix? Well, they're unmixable, which sounds a little bit like immiscible. Miscible sounds like mixable, remember that bit. Im means usually you can't do something, so it's that one. Oops. This water and oil mixture can be separated using a separating funnel. They're immiscible, they don't mix. So, this bit, dead easy, 2 marks. Firstly, the oil is less dense than water, so floats on top. Secondly, because the oil's floating on top, the water can be let out through the tap. Some people weren't sure what to call that bit at the bottom. That's the tap. I hope you found this helpful in going through the questions and breaking things down. If you need anything going through more firmly in class or you can't read my writing, go back. I usually read out what I'm saying. Thanks very much.